Let's talk about Kerberos now. What's with the name? Kerberos is Greek for Cerberus, the three-headed dog which guards the gates of Hades. Why three-headed? Kerberos is a standard specified in RFC 1510 and RFC 1964, unlike Land Manager and NT Land Manager. It's based on three types of principles. A principal is an identity that can be authenticated to a Kerberos domain. Principals include users. A user principal has a user principal name, or services. A service has a service principal name. A principal can also be a key distributor or any entity that manages keys. What sets Kerberos apart from other protocols? The protocol is based on tickets. We'll talk about this soon. An indirect impact of tickets is the ability to delegate credentials. This is an interesting functionality that wasn't available in Land Manager or NT Land Manager. The delegating feature is often used in web applications. Kerberos can be used to establish a trust relationship between networks, between two domains. A domain does not have to be a Windows domain, but it has to be a Kerberos version 5 domain. You can also prove your identity to a service, for example, to print documents on a network printer, in a way that doesn't require forwarding your encrypted password to the service. Each principal needs to have their own secret in Active Directory domains, Kerberos domains, for authentication to work. This secret is known as a long-term key. The standard defines a long-term key as a key extracted from a user's password. You submit your password, and a long-term key is generated from it. In Windows, it can also be a private key issued by a certification center. This is an expansion of the standard. How does Kerberos user authentication work? The first step is to pre-establish your identity. Your long-term key is used for this purpose. One of the strengths of Kerberos is that it doesn't overuse a user's password. It's forwarded to other nodes only when necessary. Land Manager and NT Land Manager send out passwords to all systems that request them, also without a user's knowledge. Kerberos doesn't do that. Your long-term key is sent only once to obtain a ticket-granting ticket, TGT. Kerberos forwards your password only to its trusted center. Naturally, the password is not in clear text. What is sent is a timestamp encrypted using the user's long-term key. A timestamped string is composed of date, hour, minute, second, and Zulu tag. Windows Kerberos domains always use Greenwich Mean Time. We'll also describe later a potential credentials harvesting attack. An alternative method for authentication is using a smart card. Insert a card into a card reader in a local computer and enter your PIN code. The Kerberos protocol, which operates on a different computer, will authenticate the user against the data stored on the card. This is a strikingly different arrangement from web applications deployed in banking, where an identifier is generated using, for example, a key generator, a small gadget that creates random strings of digits. You can use this mechanism also for authenticating to Windows, but this generator is not linked in any way to a domain controller. A password generator authenticates users locally. Another protocol is used later. The two authentication methods operate on two completely different security levels. Kerberos makes use of a key distribution center, a domain controller. All controllers have a key distribution center, logon server functionality. What's interesting is that a server that lets us access a printer is called a print server. A server for storing files is a file server. But a server that issues keys is called a key distribution center and not a logon server. The term can only be found in one error message. If a user tries to log on when the KDC is unavailable, you will see a prompted window. There are no logon servers available to service a logon request. A KDC has two tasks to do. Its role is to generate and manage TGTs and service tickets. A key distribution center is a machine that generates a number of random keys and manages them in some way. TGT tickets are used for authentication. They serve as a temporary password. A TGT lasts by default up to 10 hours. When it's valid, all services in a domain will uniquely identify a user based on that ticket. If you would like to use a specific service, you need to present a service ticket to that service. We'll show you the exact mechanism in a moment. A domain can have more than one key distribution center. Note that the KDCs have to share a secret. If they don't, it could happen that when one controller issues a TGT and is deactivated, a user wouldn't be able to use a network because the second controller doesn't recognize the user. To make all controllers able to share secrets, all controllers in a realm work in a KRB TGT account. This is defined in the RFC standard. This account seems inactive looking in its properties, but you shouldn't delete it. It is internally used by all domain controllers. Since this account is the same within the domain, it has the same password, the same long-term key. All controllers can exchange secrets cross-realm. A key distribution center has a secret to encrypt the TGTs it issues. A TGT ticket can be reused multiple times unless it expires or is revoked. Let's now look into the Kerberos domain authentication process. A user is not yet logged on to a computer. To be able to log on, the user has to have a service ticket. Logon is a service. A user has to authenticate with a TGT ticket to obtain a service ticket. And to obtain a TGT, the user needs to first communicate with the domain controller. A user forwards an authentication request. At this time, a timestamp is encrypted using the user Bob's long-term key and sent to the KDC. A KDC knows all long-term keys of a system's users. That's why it's able to decode the forwarded message and check the current time against the sending time. The default tolerance is 5 minutes. This means that changing the system time has a direct bearing on overall Windows security and requires administrator permissions. If a user changes the clock by more than 5 minutes, Kerberos authentication will fail. Our local system doesn't give up yet. It doesn't pop up an authentication failed message. It tries another authentication method, NT-LAN manager. If authentication succeeds, a user will obtain a TGT ticket. To be able to use a server service, you need to get a service ticket that is issued by a KDC. A user presents a generated TGT ticket. If the user is authorized to connect to a specific service, the KDC will issue a service ticket. Now you can forward the service ticket to an applicable server and use a service, provided that the ticket is valid. A server that hosts a given service can verify it by contacting the KDC. This robust solution eliminates a number of security threats, including the man-in-the-middle attack. Even if a would-be attacker gains control of user-service-server interchanges, it doesn't amount to much. The attacker would have to take over user KDC interchanges. It's easier to protect one or two key distribution centers than many service servers. We've mentioned Kerberos credential delegation. If you launch, for example, Notepad, the editor will run the credentials of the user who launched it. This is obvious. But what if a user runs a program that connects to another program running on a different computer? How is that user authenticated on a remote machine? Kerberos is the only protocol that enables delegating credentials. This functionality involves a service forwarding a user's ticket to another service on behalf of that user. It's useful for logging into websites that connect to a database server. We're visible in the server as a user who is not connected to the computer. Kerberos has only one security vulnerability, and we'll discuss it during a presentation that will show overall protocol's threats. During this module, we've talked about authentication and authentication methods, LAN Manager, NT-LAN Manager, and Kerberos version 2 protocols. We've stressed the necessity to secure system passwords. Thank you.